Chlorine parts per million, whether you're using a swimming pool or it's drinking water, you want to keep it around there. So let's go to this. Now, I think you've all seen this before. This is an Antarctic meteor from Mars, and we want to make sure that we always decontaminate our water anyway. So here's some of the nasty little critters that could get into our water, pathogens. So we're going to have to protect ourselves. Okay, how to separate out the mud? Well, we could spin this around, let the mud come down into the bottom, and then break the glass with this guy. That's called the brute force method. Or we could do this. We get ourselves a nice big plant, do some chlorination, oxidation, knock out various organics, dissolve metals, aerate it. We're going to be working with lime, which is calcium oxide, and we're going to be working with iron sulfate here. And this causes the muddy water to flocculate. It's like big giant brown snowflakes, and they're going to come down. And the bigger your snowflakes are, the more other suspended solids you're going to take out of the water. Okay, so that will loosely bond with them, and the flock will help us take whatever's still suspended in the water and doesn't want to settle out. Okay, then we're going to run through a sand filter, and we're going to use chlorination. Okay, now our workhorse compound is going to be iron sulfate, just the same as we would do on Earth. Now you'll notice over here, we could probably find iron sulfate in permafrost because it's bonded to water over here. This, if I can pronounce this right, melanterite, blue-green, relatively common. This one's relatively common, which is related to this one. These other ones are rare, so we probably won't be looking for them. But anyway, you see here mixed in permafrost. So it might be mildly acidic, but we can throw some lime in there and bring the pH back up, and we'll be doing fine. We can work between 6.5 and 8.5 on our pH in any water plant. Okay, 6 minutes. Well, okay, now we're going to load this screen up for you because we're running out of time. This is the iron bar. You recognize that. Now, if you can get some iron sulfate this way in their industrial processes they'll be doing on Mars, and you'll notice you get some hydrogen left. We could probably use it for fuel cells. There you can see the iron. I think most of you recognize it. I don't know what this is. I found this in the Wikipedia. It's something about titanium dioxide processing to get this iron sulfate. There's two kinds. There's a 1 and a 2. We have a 1 right there. Okay, I'm going to be looking for pyrite. This is pyrite over here. We use maybe superheated steam, throw in some oxygen in here. We're going to have to heat this up really hot. And it's going to break down, and we get iron sulfate here, and we're going to get some sulfuric acid over here for some more industrial processes. And there you have it. So that's probably what we'll be doing. Okay, this is a little bit about how iron is used. We'll just skip that. I think you could probably find that. This is inside a plant. This is for plant water, basic flushing toilets, running your sinks, washing down tanks and so forth. This is a sand filter. Okay, this is the bottom of the sand filter. This is their walk through here. You have a main going this way and a main over here. This is effluent. The water's coming down through here. Backwash, water goes up here. We have a big check valve right here so the sand doesn't damage our impellers after we shut off the backwash. And this is your drain in case you want to drain the whole tank. Now, water plants on Earth, you'll go in there and sometimes you'll notice that there is an aquarium. This aquarium is, in case these rainbow trout start acting funny, we have to shut the plant down and find out what's going on. You know what I mean? This is an emergency. So they're not there for looks. Okay, your weir water, what I call these are like little weir wells, and it goes over here, drops down in here somewhat, we're off the picture, goes down here and flips over the side here, and on your way out to maybe irrigate your crops, or we're going to send it to the sand filters or the sedimentation, depending on how much mud we were able to take out. Now we can assume, based on what we think we know, using my system, unlimited growth, you can build your colony as fast as you want. Okay. We assume we're going to find nice clear water in the permafrost somewhere that's not too brackish, 20 to 50% water. It's going to be salt-free or nearly so. We might find some perchlorate, but we can manage with the perchlorate. It's not very much, and I have a solution for that. We can use the methane that we're going to be using for other things to warm us and also melt our permafrost. We're going to be pre-chlorinating the water probably with ultraviolet and chlorine. It'll probably bleach in the sludge, so we don't really have to worry about it, but it's just to kind of, in case we can't unknown life, we're going to have to protect ourselves. Skim it, send the water that you see here off to irrigation. The leftover mud is actually going to be for building adobe projects and so forth. You know, build, baby, build is what I have there. You're going to have lots of sludge to build all the adobe you want. There it is. About my method produces millions of gallons. The reverse osmosis is a little bit slow. Desalination, there's problems in these two here. I hear. Also, you're going to have to keep manufacturing membranes for your reverse osmosis, and it's very caustic. Okay, we'll just go. That was another thing on that. Okay, pH around 7.6. Phoenix Lander found about pH 8.3. We can grow asparagus in that. Perchlorate's only 0.6%. We can knock that out with the iron sulfate. It'll take it right away. So you don't have a problem. There we are right there. You're going to probably be around 15 degrees centigrade for drinking water. Okay. It takes 3 times longer for Mars sedimentation because of the gravity. So we're going to look at this little guy would say, it's all about the gravity. So there's the size of our sedimentation tanks. It's going to take 24 hours of what you can do on Earth in 8. And that's not a problem. This is what a sand filter looks like. Here's a drawing of a weir. The water comes in here, goes over, goes down into the sand filter, down into the gravel. These are leach lines. This is your effluent here, filter wall. We'll just keep moving along. This is filtration. I was going to suggest that we could do an air purifying with trees here, but we probably won't do that for a while. This is water purifier, I mean. This is on top of the filter. I saw this in Indiana. Somebody was doing that. We could use the lava instead of the sand, though, grind up the lava. If we get any exotic gases, we're not going to worry about it. We're going to probably just vent it out. We don't have to worry about the EPA or anything like that. If it's chlorine or something we can't handle, we can just vent it outside, including sulfur dioxide. If we get an exchange in there from the sulfates and we get that nasty smell, we can vent that. We'll probably get industrial uses for most of that stuff, and also the adobe. This is also being mentioned down here. Let's see, if we get too much water, we can make a lake that'll freeze outside. We can use it for transportation. I'll show you in just a minute. We have to keep going. When we do our crops, we can export things. We can use railgun technology. They're up to about 13,000 miles per hour now. We're going to be safe from famine on Earth and weather disasters. It's more dependable if we grow our crops using the water that we would be making. And the lava flow makes fantastic vegetables. I'm going to tell you that I think the food that comes out of Mars is going to be better than most of the food on Earth. There's the railgun technology. We'll just go on by that. Okay, this is mining all that water. Earth coefficient of ice rudder, you might want to write this down. 0046, you might want to play with that somewhere. I took this down to 0.38 of this, and I got this 00175. We bring this up to 250 miles an hour in a trench. Here's ice, kind of like a bobsled. This is how we're going to go get our ice. This is called the Zamboni ice train. We invented this last night. You use a little rocket here, and if you run into some dust, you're going to be throwing water out a little bit, wasting a little bit of your water. This could be a multi-train, a unit train. You throw some water out the back for the next guy that's going to come by, just to make sure you got enough ice down there. Don't worry about sublimation. If you keep adding ice, and you're going to be running, several times a day, you don't have to worry about that because you're going to have, the ice is going to stay there long enough for you to do this. So, okay. And there it is. That's all about the train. We can probably discuss that at another time. We'll be able to launch space shuttles that way also. Here's your rails. Okay, live a good life on Mars. Folks will find out once you are on the ground, living among others, life can be good whether on Earth or Mars as long as there is clean air, food, and water. So, we can live just like we do on Earth, go shopping, eat in nice restaurants. I doubt we'll see New York-style buildings soon, though. Here's King Kong up there. I don't think we'll have any skyscrapers for a while. We'll be eating out, and I just want you to, don't worry, be happy, enjoy Mars. And this is the Mars chapter right here. Sorry about the sound at the beginning. I had to be the first one, so that means that I had to deal with all the problems. And I just wanted to let you know there's a 360-degree view of Spaceship One that landed in Dayton up here on my website that I work on. And this is my email address if you want to write that down, ask me any questions you weren't able to ask me today. I suggest you get that number because it looks like we're going to be done here in about 30 seconds. And I am welcoming convention photos. I didn't bring my camera because I got a scratch on my lens and it's really not going to make nice pictures right now. And you can exchange ideas, you know, about where the next. Well, we were learning about it's in Texas, but anyway, you just go ahead and send me emails, send me pictures, send me ideas, and you know, I'm willing to talk to you about it. Also here, Mars toys on page 2. I've got some paper airplanes up here. If you want to give them to your kids or something, go to page 2, click on Mars toys, and get some paper airplanes. And that's about it. Any questions? If we have any time, I think we're done. The lights, please.